Hello everyone and welcome to tutorial number 51 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about annotations and autoboxing. So we are going to continue from where we left in tutorial number 50, the last tutorial. So in this tutorial I'm going to talk about annotations, and if we get time we'll be talking about generics as well. Okay, so we'll be looking into all those concepts with the help of the IDE. So let's get started right away. So first of all I'm going to talk about marker annotations. Okay, so if I talk about marker annotations, okay, if you remember, I told you in the previous tutorials itself, when I discussed the concept of marker annotation, that marker annotations are those annotations which don't have any members defined inside them. All right, so that is exactly what this my annotation is all about. It is an annotation which contains no members inside it. Okay, so by members I mean the methods. Okay, if you remember how the annotation is defined. So this particular my annotation, it has no member, okay, no function defined inside it. So now if you want to use this particular marker annotation, it is as simple as simply writing my annotation over here. Okay, and if you look at the target of this particular annotation, it is going to target a type. So you can use this my annotation in front of a class or in front of enum. Okay, it is valid here as well. All right, and it is valid in front of interface as well. Okay, so it is valid in front of a interface, in front of a enum, and in front of a class. All right, and this is how we are going to use this is the definition of the my annotation. Okay, this is the definition of the marker annotation, I should say. My annotation is the marker annotation, and this is how we are going to use a marker annotation. Okay, simply we are going to write @my annotation. Okay, because ultimately this particular annotation, it is not having any member inside it, right? So you can simply write @my annotation and this becomes a marker annotation. Okay, so now if you want to use the concept of reflection, that is a completely different concept which will be using later on. But first of all I'm going to talk about marker annotation. So if you talk about marker annotation, then it has no members. I already told you that. And this is how we are going to use a marker annotation. Okay, simply write then the name of the annotation. Okay, so this is how we are going to use a marker annotation in front of enum, also in front of interface also. Okay, so this is all about marker annotation usage. Okay, and definition is provided here. And if we talk about single member annotation, okay, if I talk about single member annotation, then here you need to define int value. You need to define a member known as int value. If you remember in the single member annotation, I already told you when I used the PPT, that you need to define a member named as value. Okay, if you remember that. Okay, and here you can write like let us say 100. Okay, now one thing to keep in mind is that if you name this as value, then only you can write this as in this manner @my annotation. Then simply you can open the bracket or the parenthesis, then write 100 over here. However, if you write anything apart from value here, let us say I'm writing int length or something like that. Okay, anything apart from a value, then here you need to ensure that you need to write length over here. Okay, so this is the thing which you need to keep in mind. And this particular thing, int length, it is a kind of single member annotation. As the name itself suggests, it is an annotation which has a single member. Single member means exactly one member. Okay, so here this my annotation, it has exactly one member and the name of the member is length. Okay, however, if I don't want to use this length, if I want to use value, then you can simply write 100 here. Okay, in much the same manner you can repeat the same thing here as well. My annotation, let us say 50. Okay, and here let us say my annotation 30, 49 or something like that. Okay, so in that manner you can define the values, and here also you can define the values, let us say 20. Okay, so in this way you can define the value. Okay, you can provide the value, because ultimately what I'm doing here, at the rate my annotation, I am simply writing value equals 100. Okay, indirectly I'm writing value equals 100, but there is no need to do this. Okay, there is no need to explicitly mention value equals 100. You can simply write it as 100. Okay, even if you write value equals 100, it is not going to give any error, or it is not going to give any warning. That also you need to keep in mind. But however, it is always best to specify just like 100. But if you need to keep in mind that for this particular statement to work, at the rate my annotation 100, or at the rate my annotation 50, or at the rate my annotation 49, okay, the name of the member has to be value. Okay, you can test it from your side also. I have shown you just a couple of minutes ago. If you write length here, okay, instead of value, then it is going to give an error. Okay, and I'm going to show you this once again. If I change it to length, it is going to give 4 errors. Okay, so I'm going to return here, and it is going to give error here as well. Okay, cannot find method value. You can see here it is giving error right away, cannot find method value. Okay, the reason is because if you define this instead of length, if you define it as value, okay, this thing will be perfectly valid. Okay, so this thing will be valid only if you provide this particular method value. In any other case, okay, if you define any method apart from value, then this particular line, it is not going to work. Okay, so please keep that in mind. Okay, later on don't get confused at why the compiler is giving an error. Okay, so if I define length here, then if I define length here, then you need to mention it like this. Okay, so in this way you need to mention it, length equals to 100. Okay, in much the same manner, here also you need to provide length equals 50. Here also you need to provide length equals 49, and in example also you need to provide length equals 20. Okay, so I hope I made myself clear, okay, in this particular scenario of single member annotation. And apart from that, we have built-in annotations as well. Okay, if I talk about built-in annotations, okay, then the thing to keep in mind is that there are around 4 or 5 built-in annotations. We have retention, we have target, we have inherited, we have deprecated, we have suppress warnings. Okay, so now we have retention. So let me show you this retention right here. Okay, now we have this retention here. Why is giving the error? Okay, all right, so now we have fixed all the errors. So now I'm going to show you this retention. If you remember, this particular annotation, it is going to determine when this particular annotation, okay, when this particular my annotation is going to get discarded. Okay, because this annotation, it is used on annotation, another annotation. Okay, so this particular retention, it is going to determine when this particular my annotation, it is going to get discarded. Okay, so right now the retention policy is runtime. Okay, so because of that reason here it is working perfectly fine. But what is going to happen if I make this as anything apart from runtime? Retention policy, let us say source. Okay, then after this I am using my annotation here. Okay, it is not going to create any problem right here. But now I am going to use the concept of reflection. Okay, I am going to use the concept of reflection. Okay, and always remember one thing, this reflection is always determined during runtime. Okay, so now let me use reflection. Okay, so for using reflection, first of all you need to use the get class method. Okay, there are 2 ways to get the class of a particular class. Okay, so get object of a class, I should say. So first way is that you can create object of this tutorial. Then after that you can use the get class method. Okay, so that is the first method. And the second way to do this is by using tutorial dot class. Okay, and I suggest using this one instead of using object version new tutorial.get class. Okay, so because this is an easier way to do the things. Then dot get annotation. Okay, dot get annotation tutorial, not tutorial, sorry, my annotation dot class. Okay, so now here you can see that it is getting highlighted, and here you can see the reason why it is getting highlighted. This particular annotation, it is not getting retained for reflective access. Now as I told you, just 1 or 2 minutes ago, this is the concept of reflection. Okay, so what I'm doing, I'm getting the object of the object of the class which is defined in Java. Okay, I'm talking about this class, remember. Okay, I am getting the object of this particular class T, which is defined in java.lang package. Okay, so I am getting the object of this particular class, java.lang.class with a capital C. So I'm getting the object of this particular class. Okay, so the way to do this is by using tutorial.class. Okay, or you can use new tutorial.get class. Okay, so you can do this particular thing as well, new tutorial.get class get annotation. Okay, so the concept is going to remain the same. Okay, either of the statements is going to work. Okay, so here also what I'm doing, if I click on if I hover over get annotation, you can see java.lang.class T. That means this particular method, it is defined in this class. Okay, and the name of the method is public. This is a generic method. Okay, it is a generic method, get annotation. Okay, and here also if you hover over get annotation, here also you can see java.lang.class T. So you can use either of these methods. Okay, it is completely up to you, but here you can see that it is not retained for reflective access. That means reflective access means I'm using reflection here, right? I'm using the concept of reflection, but this particular class, it is not retained for reflective access because this particular annotation, I should say, it is retained, it is discarded during the source itself. And the same policy is going to apply if I use same thing is going to apply if I use class also. Okay, so if I saved it now, and if I return here, then also the same thing is going to come. It is not retained for reflective access. Okay, so I already explained the concept of this retention policy. So if you have doubts, you can watch one of my previous tutorials. Okay, I have mentioned about this retention policy over there in detail. And as soon as I change it to runtime, that particular warning is going to go away. Okay, so what does this mean? If this retention, it is going to determine whether this particular my annotation, it is going to get discarded during runtime or during source or during class. All right, so that is what this retention is going to be used about. I think I already discussed the concept of target in an earlier tutorial. Okay, I already told you, if you remember, element type dot type, element type dot annotation type, element type dot constructor, field, local variable. I already discussed this in enough detail, if you remember. Okay, so I'm not going to repeat the same thing again here. So then after that we have inherited. Okay, now this inherited is a very interesting concept because let us see how this concept is going to work. So here I am going to define inherited. Okay, now one thing I'm going to do is I'm going to go to example. Okay, then after that I'm here I have already defined my annotation. I have already used this particular annotation. Okay, now remember one thing, this my annotation, it is inherited. Okay, I'm using this inherited annotation here, and in example I have used this my annotation. Here I am going to remove this my annotation, and what I'm going to do, I'm going to extend example. Okay, you're going to see what where I'm getting to very soon. Then after this I'm simply going to use reflection. Okay, I'm simply going to use reflection. So let us use reflection, system.out.println. so tutorial.class. Okay, tutorial.class dot is annotation present. Is annotation present. The name of the annotation is my annotation dot class. Okay, so now you will be wondering that whether this is going to show true or false. Okay, by your logic, actually the answer should be false, isn't it? We are not using my annotation here. We are not even defining my annotation here. So obviously the answer should be false. But is the answer really going to be false? Let us see what the output is going to be. So the output is going to be, okay, it's taking time. So let us wait till the output is comes on the screen. Okay, it is building the entire program. It is taking a lot of time. I'm sorry about this. You cannot speed up the process, right? It all depends on the computer. So the output should be a few seconds away now. Yes, now you can see the output is true. Okay, so obviously you would have expected that the output should be false, but the output is not false, the output is true. Now the reason why the output is true is because we are using the inherited inherited annotation here. Okay, inherited annotation means now this particular annotation, we are using this annotation in front of inherited annotation in front of my annotation, and we are using my annotation in front of this particular class example. Okay, and we are deriving this particular class example over here. Okay, so basically this particular annotation, it ensures that if you are using this particular my annotation in front of a base class, then all the child classes whatsoever it is going to derive from example, they are automatically going to inherit the base classes annotation. Okay, like if I write my annotation here, it is just similar to writing my annotation here as well. Okay, instead of writing my annotation here, if you simply extend example and if you use inherited annotation, okay, then it is just equivalent to writing this one. Okay, that is the reason why it is showing true. Okay, is annotation present means it is going to return true whether the annotation is present in the particular element. That means this particular annotation, my annotation, it is defined in tutorial. Okay, it is used in tutorial. That is why it is returning true. Otherwise it is going to return false, right? So that is the concept of inherited annotation. After that we have deprecated. Okay, deprecated is actually very easy to we have already used deprecated constructors, if you remember. Okay, we have used that in I think in one of the previous tutorials, I think, when we used the type wrappers. Okay, we use deprecated constructor, if you remember. It is not going to give any warning, it is not going to give any error, but it is going to give a warning. Okay, like for example public let us say I'm defining tutorial. Okay, I'm defining a public constructor and I am going to deprecate this. Okay, and if I try to use this new tutorial, that means I'm calling this particular thing, I'm indirectly calling this particular constructor. So it is going to give a warning, deprecated member is still used. Deprecated means it is kind of obsolete. Okay, something else is there instead of using this constructor, you can use something else. That is the meaning. Okay, so deprecated means mostly it is obsolete, it is no longer in use. Okay, you should use something else instead. Now suppress warnings, if I talk about suppress warnings, okay, like for example right now if I write let us say tutorial dot class dot get let us say annotation, get annotations, let us say. Now this particular thing, it is not giving, yeah, this particular thing, it is going to give a warning, result of class, it is ignored. The reason why this particular warning is coming is because this particular method get annotation, it is not returning a void data type. Okay, it is returning a array of annotation. It is returning the array of annotation as a return type. So because of this reason, the compiler is warning you that you are trying to use this method, but you are ignoring the return type. It is trying to warn you about the consequences. However, if you don't want this particular warning to appear, what you can do, instead, in front of this main method, you can write suppress warnings, and you can write all. Okay, so by doing that, what happened, this particular warning went away. Okay, this it was highlighting earlier. Okay, so if I remove the highlight by using comments, once again the this particular get annotation is getting highlighted. So basically this particular annotation is used to remove any particular warning. Okay, so that is what this particular thing is used for. Okay, and so I think we have talked about marker annotations, we have talked about single member annotation, we have talked about built-in annotations as well. Okay, we have used the concept of reflection also, but one thing you need to keep in mind is that the concept of reflection is very vast. Okay, so for example, let us say I want to find annotation which is defined on a particular method. Okay, like for example tutorial dot class dot get method. Okay, get method, then I should write the name of a method, let us say main. Okay, I am referring to the same main method only. Okay, main, then after this, let me wait, let me see what is main. Okay, get method. So I think the parameter is, wait a minute, parameter is, okay, so first of all it is a name of the method, then the second thing is this parameter. Okay, so it is accepting the string parameter, that's why you are doing this. Then after that you need to write get annotation. So you can use by this you can get the annotation which is defined on this particular method. Okay, main method. Right now no annotation is defined. Okay, but if you define if you write this get annotation, and after that if you want to or if you want to check whether particular annotation is present or something like that. Okay, is annotation present or not? Let us say I am going to write suppress warnings. I think it is giving an error that suppress warnings dot class. Okay, then here I am defining suppress warnings all. Okay, then after this if I print this particular value system.out.println, then it is going to return true. Okay, I think it is going to give an error, sorry about that. I accidentally clicked yes instead of doing Control S, which is used for saving the file. I'm sorry about that. I think it is not going to run right now. So okay, let us wait what is going to happen. Yeah, it is returning false, actually it is returning false. Okay, but this is a one of the way to find out whether, okay, instead let me use some other value here. Instead of suppress warnings, let me use my annotation, and let me use my annotation here. Okay, and then you need to remember that you need to change this to element type dot method. Okay, let me click on the run button now, and let me see what the output is coming as. I'm sorry about this, guys. Computer has got a little slow now. I'm extremely sorry about it, but I don't know why it is running so slow today. Earlier it used to compile and build within a couple of seconds or within 5 seconds, but right now it is taking a little bit of time, so I am extremely sorry about that. Okay, so let us wait for the program to execute. How much more time is going to take? Okay, annotation type not applicable to this type of declaration. Okay, fine. So now I'm going to press the run button again, and once again it's going to take time, I think. So I think we will leave it at here. I think after the I will end this tutorial after this particular output is shown. Okay, so this particular, the concept of reflection is very vast, so I don't think we will be able to do each and everything. We will be able to use each and every method present in reflection. Okay, I don't think it is possible. So we will we will going to discuss the concept of generics in the next tutorial. Okay, so that's all I'm going to talk about in this tutorial. Let me just show you this output. Okay, another error is going to come in the enum. Okay, let us hope the error goes away. Sorry about this. I don't know why the laptop has got so slow today. Okay, so finally it is showing true. Okay, so I'm extremely sorry about that. Actually, since I changed this to method, right, but I kept the @ my annotation here as well, @ my annotation here as well, and here as well. So because of that reason, as I told you, the concept of this target earlier itself. Okay, if I use this target element type that method, then we can use this my annotation only in front of methods. But I had already defined I had already used @ my annotation here, and here as well. Because of that, it was giving an error. Okay, and laptop was also taking some time to build the programs. I don't know why, but in any case, that is going to be the end of this particular tutorial. So in the next tutorial, we are going to be talking about generics, generic classes, generic interfaces, generic methods, and generic constructors. And one additional thing I would like to add is that you should do your own research on reflection also. Okay, because I cannot do discuss each and everything in the tutorial, because I also run out of time if I discuss each and everything. Okay, but if we get time, we will discuss these methods in a future tutorial. But for now, that's all I'm going to talk about in this particular tutorial. If you have any kind of doubts or any kind of questions, then don't forget to post in the comment section below, and I will get back to you when I can. And if you liked this particular tutorial, then don't forget to like, share, and subscribe. And yeah, I will see you in the next tutorial. So till then, bye.